Alright, in this problem we're given y is equal to sine of 2x to the power of tangent 2x. And we're going to find dy dx, the derivative. Okay, so in order to do this, we're going to have to use logarithmic rules because we don't want this tangent 2x staying up in the exponent there. So I'm going to take the natural logarithm of both sides. That'll give me ln of y equals ln of the other side, which is sine 2x to the tangent 2x power. Okay, now how does that help us? Well, logarithm rule says that we can, when you have an exponent, you can bring the exponent down and put it out front. So that means we have ln y equals tangent 2x times ln of sine of 2x. Okay, so we still haven't taken the derivative, but we've got the tangent 2x out of the exponent. Okay, so when we do this, now that we have it this way, we're going to have to implicitly differentiate this, which means that the ln of y, it's not solved for y, it's solved for ln of y. So we need to take the derivative implicitly, which means the derivative of ln of y is 1 over y, but then we'll write a dy over dx there. Okay, we'll come back to that 1 over y in a minute, but let's go ahead and take the derivative of this using the product and some chain rule. Okay, so recall that the product rule is the first times the derivative of the second plus the second times the derivative of the first. So the first is tangent of 2x times the derivative of the second one here. The derivative of an ln of u is du over u. Okay, so the derivative of the inside divided by the inside. Okay, so the derivative of sine of 2x, it's got the 2x in there, so it's a little chain rule there. You put the 2 on the outside and take care of that. So the derivative of the inside, du, is cosine of 2x times 2. The 2 comes from the chain rule. Okay, derivative of the inside there. And remember, it's du over u. This is u, so we just rewrite the inside on bottom there. Okay, so that takes care of the first half of the product rule. First times the derivative of the second. Now we need to do the second times the derivative of the first. Okay, so the second times the derivative of the first, well, the derivative of the first is secant squared of 2x times 2. And then we just rewrite the ln of sine of 2x. Okay, so that's the derivative, but man, it needs to be cleaned up a lot. Okay, so we'll leave the 1 over y for now. We'll leave that over here. We'll take care of it in the next step. But in this step, let's try to clean up some stuff. Okay, recall that tangent is the same thing as sine over cosine. Okay, so if we wrote that as sine over cosine, it would be sine of 2x over cosine of 2x times cosine of 2x over sine of 2x. And don't forget we have that little 2. Don't want to forget that out front. Okay, you'll see what's going to happen there, right? Okay, so that cross multiplies and cancels completely out. And now for this one, we can rewrite that. Let's rewrite the secant as a cosine and put it on bottom. We'll leave the 2 and the ln on top. So plus 2 ln of sine of 2x over cosine squared of 2x. Okay, let's go ahead and reduce. So this cross reduces, okay, and it leaves nothing but a 2 there. So we've got 1 over y dy over dx equals 2 plus 2 ln of sine 2x over cosine squared 2x. Okay, let's do one more thing before I take care of that 1 over y term. Let's combine these two terms using a common denominator. So we could factor the 2 out front, which would be fine. Then it would leave a 1, and then we need a common denominator, which would be a cosine squared. So in other words, this term would be a cosine squared on top and bottom. I'll leave the 2 in there. So dy over dx equals 2 cosine squared 2x plus 2 ln of sine 2x all over cosine squared of 2x. Okay, so I didn't factor out the 2. I can if you want. You don't have to. Okay, now let's take care of the y. So the 1 over y doesn't need to be there. We really just want the dy dx. So we have to go back up to the original equation and look at the y is equal to what it is. Okay, so we're going to substitute the y for this. Okay, so we'll multiply the y over first. So dy dx equals, let's also factor out the 2. So 2 times y, and then have a big parentheses here, cosine squared 2x. Let's just write all this again. Okay, and the last step is to just substitute what I said, the sine 2x to the tangent 2x power, and that'll be it. So here is our final answer, equals 2 times sine 2x to the tangent 2x power, all times all this stuff, which is cosine squared of 2x plus 2 ln of sine of 2x all over cosine squared of 2x. And that is your derivative.